Let's do one more quick video. This is the triangle angle bisector theorem. Usually you see it just called the angle bisector theorem, but this is a little bit more precise. That when you have an angle here, O or POT, in a triangle and you bisect that, it's a very common thing to do, is you've got an angle bisector. That angle bisector, of course, is going to intersect that opposite side at some point. Here I've got that marked as U. And what's that going to do? Well, turns out that similar triangles can be used to analyze this. I'm going to do that in class because I think that'll be more fun to do that together. And it is going to create certain proportions. Okay, so let's just look at the result in this video. Just make it nice and quick, and we'll try to make it at least plausible. If this ray from O towards U is halfway in between the OP side and the OT side, I guess the way I think about it is, as if I'm walking along OU and I go further and further and further, I notice that side is getting further and further away, and PU is a certain measurement of kind of how far I've gotten away from the OP side. Now, it's kind of a measurement using this slanty line, but here's the thing. If I measured also as I walk along OU, how far I'm getting progressively further from the OT side, what if I also use the same slanty line to do the measurement? Is that going to give me something reasonable? In fact, it does. Okay, so PU over OP is kind of a measure. It's a rough measure of sort of how big this angle POU is, because it's telling me how far I've gotten away from the OP line as a proportion of sort of how far I've gone in the direction of OP. Similarly, TU over OT is a measure of how far I've gone away from the OT line, again in a kind of a funky slanty way. But it turns out, as long as I use the same slanty line to do those measurements, then those ratios are going to be equal. I have a proportion. So in words, that upper crossbar part, or you can call it the left in this picture, over its corresponding side is equal to the ratio of this lower crossbar part over the lower side. And of course, you can rearrange that, that proportion. You could also compare like PU over TU. So the upper versus lower on the crossbar is the same as upper versus lower on the sides of the original triangle. Again, the kinds of things you can always do by messing with proportions. So let's just do a quick example with some variables in here. If this happens to be x, 2x plus 2, 5x plus 2, 3x minus 2, kind of artificial, gotta admit, set up to test our algebra chops. But it's very common that at least one of these guys will be unknown. And so what do I get? I get, using that original form that I showed you, left or top part of crossbar over corresponding side of original triangle. That's x over 3x minus 2. That's equal to 2x plus 2 over 5x plus 2. That's all going on the other side of the triangle. Cross multiply 5x squared plus 2x when you multiply the 5x plus 2 times x. Cross multiply these guys. There you actually have to FOIL it out. 2x times 3x is 6x squared. 2x times minus 2 gives you a minus 4x, but then plus a 6x. All told, it's plus 2x. And then minus 2 times 2 is minus 4. Turns out, all but one of the x squareds cancels out. The 2x's do cancel out. And if you move the 4 over to the other side, you get x squared equals 4. Now remember, x is something that's going to go into a geometric diagram. So we want to look at both the plus 2 and the minus 2 answers. And we can't actually just say, oh, it's obviously just plus 2. Minus 2, definitely not, because here's x, that would be negative. 3x minus 2, if x is minus 2, this would be negative, not legal. You got to check the 2 as well, though, because notice this guy, 3x minus 2, that is the dangerous one. This could be negative even if x is a small positive number. Now, it happens to be that if x is 2, this is 4, 2, 6, and 12. We're all good. They really are all positive. So it's not just that whatever the variable is needs to be positive. You really got to plug it into all these expressions for the sides and check that the sides all end up being positive. And that's my dog Rosa saying it's time to end the video.